Hi guys, welcome back to my channel Chemistry Tips. Today we discuss the topic green chemistry. Very important topics and questions are discussed here. If you like this video, please subscribe and share. What is green chemistry? It is the design of chemical products and processes that reduce or eliminate the use or generation of hazardous substances. Green chemistry is also known as environmentally benign chemistry or sustainable chemistry. It is one of the question, the other name of green chemistry. Green chemistry is also known as environmentally benign chemistry or sustainable chemistry. The principles of green chemistry. There are 12 principles in the case of green chemistry. Paul Anastas and John Warner formulated the 12 principles of green chemistry in 1998. First one, waste prevention instead of remediation. That is, it is better to prevent waste than to treat or clean up waste after it has been created. Second one, atom economy or atom efficiency. Synthetic methods should be designed to maximize the incorporation of all materials used in the process into the final product. Percentage atom economy equal to molecular weight of desired product divided by molecular weight of all reactants into 100. Third one, use of less hazardous and toxic chemicals. Wherever practicable, synthetic methods should be designed to use and generate substances that possess little or no toxicity to people or the environment. Fourth one, safer products by design. That is, designing safer chemicals. Chemical products should be designed to effect their desired function while minimizing their toxicity. Next one, safer solvents and auxiliaries. The use of auxiliary substances, example solvents or separation agents, should be made unnecessary whenever possible and innocuous when used. Water should be used as a solvent. If water is not usable, then more eco-friendly solvents like supercritical CO2 or ionic solvents. As far as possible, synthesis is carried out without solvents. Next, energy efficiency by design. Energy requirements of chemical processes should be recognized for their environmental and economic impacts and should be minimized. If possible, synthetic methods should be conducted at ambient temperature and pressure. This can be achieved by use of proper catalysts, enzymes, use of microorganisms for organic synthesis, use of renewable materials. Preferred use of renewable raw materials. A raw material or feedstock should be renewable rather than depleting whenever technically and economically practicable. Shorter synthesis or avoid derivatization, that is, reduce derivatives. Unnecessary derivatization, that is use of blocking groups, protection or deprotection, and temporary modification of physical or chemical processes should be minimized or avoided if possible, because such steps require additional reagents and can generate waste. Catalytic rather than stoichiometric reagents, because catalytic reagents are superior to stoichiometric reagents. Catalysts make the reaction faster, decrease the energy requirement, minimize waste. Design products to undergo degradation in the environment. Chemical products should be designed so that at the end of their function, they break down into innocuous degradation products and do not persist in the environment. Example, polyethylene, polystyrene are not biodegradable, but biodegradable polymer like polyhydroxybutyrate, hydroxyvalerate. Synthetic insecticides remains in the food grains and vegetables and do not get degraded, but natural insecticides, example chili, neem, etc., get easily degraded after killing the insect. Analytical methodologies for pollution prevention. Analytical methodologies need to be further developed to allow for real-time in-process monitoring and control prior to the formation of hazardous substances. Inherently safer process, that is, safer chemicals for accidents prevention. Analytical substance and the form of a substance used in a chemical process should be chosen to minimize the potential for chemical accidents, including releases, explosions, and fires. That means the reagents and reactions should be risk-free in the chemical process to minimize the chemical accidents, explosion, fires, and gas release. Bhopal gas tragedy is an example. A plant accident in Bhopal, India released methyl isocyanate. Nearly 4,000 people died. Green chemistry is reducing waste, materials, cost, energy, hazards, risks. Once more, green chemistry reducing waste, materials, cost, energy, hazards and risks. Green solvents in green chemistry: water, methanol, ammonia, pyridine, acetonitrile, HMPA, DMSO, DMF, ethanol, acetone, nitromethane. These are the examples for green solvents. Water is one of the good alternatives of volatile organic compound. It is very cheap, readily available and plentiful. So, it is the most one of the greenest solvent. Carbon dioxide, like water, it is readily available, natural, cheap, plentiful. Already being adopted in a variety of commercial processes. It is non-toxic, easily removed and recycled, and can be disposed of with no net increase in global carbon dioxide. No solvent effluent. Ionic liquids typically consist of organic cation and inorganic anion. Usually consider ionic liquids which are liquids at room temperature. Great variety of structures possible. Very low vapor pressure. Alternative reaction condition: reduce or eliminate solvents used in reaction media, separations and formulations. Use of supercritical fluids as solvents. Example, water and carbon dioxide. Use of aqueous solvent system in place of organic solvents in chemical manufacturing. Use supercritical CO2 as a solvent. Reduce operating temperatures. Who is the father of green chemistry? Answer, Paul Anastas. Paul Anastas is the father of green chemistry. It is very important question. According to green chemistry, the chemical involved in the production must be dash, non-toxic, toxic, highly toxic, produces the toxic byproducts. Answer, non-toxic. According to green chemistry, the chemical involved in the production must be non-toxic. The atom economy obtained for green synthesis is in the range of options 62 to 70%, 72 to 82%, 40 to 50%, 90 to 100%. Answer, 70 to 82%. The atom economy obtained for green synthesis is in the range of 72 to 82%. If the reaction is rearrangement reaction, then the percentage of atom economy is mostly 100%. In green synthesis, by avoiding harmful byproducts, the catalyst used is dash. Options, tungsten, benzene, cyclohexane, adipic acid. Answer, tungsten. In green synthesis, by avoiding harmful byproducts, the catalyst used is tungsten. All the other are cyclic elements. They produce some harmful materials as they are carbon compounds. Green chemistry is also called as dash, life chemistry, environmental chemistry, organic chemistry, sustainable chemistry. Answer, sustainable chemistry. Green chemistry deals mainly about the pollution, variation in environment and the sustenance of the plants and animals and mankind in a healthy manner. So this is also called as the sustainable chemistry. A desirable green solvent should be dash. Options, costly, toxic, readily available, synthetic. Answer, readily available. A desirable green solvent should be readily available. The desirable green solvent should be cheaper. It should be safe and non-toxic. It should be natural. An ideal solvent facilitates the dash, mass transfer, dissolving property, combustion, titration. Answer, mass transfer. An ideal solvent facilitates the mass transfer. Water is called as universal solvent. Any solute can be dissolved in water and facilitates for mass transfer. The green solvent maximizes the atom dash. Options, molecular weight, electronic configuration, velocity, efficiency. Answer, efficiency. The green solvent maximizes the atom's efficiency. For example, benzene can be replaced by the toluene, cyclohexane instead of carbon tetrachloride can be replaced. Dash are greener than the conventional methods. Options: microwaves, electromagnetic waves, ultraviolet waves, radio waves. Answer: microwaves. Microwaves are greener than the conventional methods in organic synthesis without solvents. The wide range of the microwave chemistry is extended recently to many aspects of organic synthesis. Self-thermoregulated systems are called as dash: green methodologies, green synthesis, green principles, green concepts. Answer: green methodologies. The self-thermoregulated systems are called as green methodologies. Soluble polymers are another example that comes under green methodologies. Green chemistry improves dash of chemical manufactures. Options: competitiveness, easiness of production, services, chemicals. Answer: competitiveness. Green chemistry improves competitiveness of chemical manufactures. The products are low cost and good quality, so it improves the competition. Microfluid reactor will minimize dash. Options: solvent waste, efficiency, number of molecules, number of collisions. Answer: solvent waste. Microfluid reactor is used to minimize the solvent waste. When the reaction takes place, there will be a product sometimes useful but sometimes unnecessary. Such waste must be reduced. Which of the following is the greenest solvent? Options: formaldehyde, benzene, ethanol, water. Answer: water. In the late 1960s, the Cuyahoga River in Ohio overloaded with chemical pollutants and dash. Options: killed fish, polluted surrounding soil, caused foaming, caught fire. Correct answer: caught fire. In the late 1960s, the Cuyahoga River in Ohio overloaded with chemical pollutants and dash. Killed fish, polluted surrounding soil, caused foaming, caught fire. Answer: caught fire. Shortly after midnight in 1984, a reaction caused poisonous methyl isocyanate gas to leak from a factory in this city dash, causing 3,700 deaths. Options: Bhopal, Hingli, Calcutta, Siberia. Answer: Bhopal. Shortly after midnight in 1984, a reaction caused poisonous methyl isocyanate gas to leak from a factory in the city, that is Bhopal, causing 3,700 deaths. Dash is an excellent green solvent as well as a greenhouse gas. Options: methanol, CFCs, carbon monoxide, carbon dioxide. Answer: carbon dioxide. Carbon dioxide is an excellent green solvent as well as a greenhouse gas. This green chemical is used in household cleaners to remove stains and is also a favorite dressing on salads. Options: vinegar, citric acid, hydrochloric acid, water. Answer: vinegar or acetic acid. This green chemical is used in household cleaners to remove stains and is also a favorite dressing on salads. Answer: vinegar or acetic acid. An example of green chemistry is options: recycled carpet, a product made on Earth Day, a sublimation reaction, bioplastics. Answer: bioplastics. Bioplastic is an example of green chemistry. Green chemistry can reduce all but which of the following? Cost, risk and hazard, awareness, waste. Answer: awareness. Green chemistry can reduce cost, risk and hazard and waste. Green chemistry synthesis could also involve which of the following? Options: high temperature, dichloromethane, fossil fuels, microwave. Answer: microwave. Thanks for watching.